Hello my dear students, in this video we'll continue with chapter number 4 called data structures. So let us have introduction. Here data is a raw fact, figure or the statistics that is to be processed by the computer system. So here data may be a single value or it may be multi-valued data item. So let us take one example. If we write a roll number of a student, then it is a single valued data item, and if it is multi-valued such as your name consisting of first name, middle name and the last name, so hence it is called as multi-valued data item. So here the data will be arranged in a proper format onto the memory so that we can optimize the accessing speed of the program. Not only that, it also optimizes the execution of the program. So hence we use structuring the data. So structuring the data means what? Arranging the data in a proper format. So data structure represent arranging the data in a proper format so that we can optimize the speed or execution of the program. Now let us continue with the definition. A data structure is a specialized format for organizing and storing data. Now let us continue with data representation. So here data will be stored in memory for processing. It is called data representation. Data structures deals with the first one, logical and mathematical description of structure. Second one is implementation of structure on a computer, and the third one is analysis of structure, which includes determining amount of space in memory and optimization of time taken for processing. So here in this particular chapter we are going to study the first 2 points, that is logical and mathematical description of the structure we are going to study, and implementation of structure on computers we are going to study. The third point, analysis of data structures, we are going to study in a higher classes. Now let us continue with the classification of data structures. Here you can see in a picture, data structure is broadly classified into primitive data structures and one more is non-primitive data structure. Under primitive data structures we have integer, floating point, character and pointer. So all these are inbuilt data types which we have already studied. Next we'll continue with non-primitive data structure is further classified into 3 different types: arrays, lists and files. Arrays is further classified into single dimensional array, 2-dimensional array and multi-dimensional array. This one already we have studied in PU1 and even in a PU2 classes. Next, lists are further classified into linear data structure, and the next one is non-linear data structure. Linear data structure consisting of stacks, queues and linked lists. Non-linear data structures include trees and graphs. So files we have already studied in the previous video, that is the chapter number 12 called data file handling, right? So let us continue with the primitive data structures. So primitive data structures means what? These are the data structures that are easily operated upon the machine level instructions is called as primitive data structures. Primitive data structures such as int, char, float type of data. So what all different types of operations that we can perform on primitive data structures? So first one is create. It is going to create a data structures which allocates memory location statically, or it may be allocating the memory at dynamic or at the time of execution. So let us take one example. Here int x, if I declare any variable with its respective data type, it allocates the number of bytes. In this particular case, int will occupy 2 bytes of memory location. So hence x will occupy 2 bytes of memory location. Next we'll continue with destroy. So as soon as the program execution terminates, you can destroy or deallocate memory occupied by the variable. In destructors we have studied the memory which is going to be allocated by the constructor will get deallocated by the destructors in C++. Next is select. Select is used to access the data item from the data structure. Next, update. So here update is nothing but changing the value of the variable is called as updation. Let us consider the example. Here int x is equal to 2. After writing x is equal to 2, again I am going to initialize the same variable with a different value. So means what? It is updated with the value, that is new value. Earlier it was x is equal to 2, now it is x is equal to 4. Non-primitive data structures. So these are the data structures which are very much complex data structures, but they are the one which is derived from the primitive data structures. Let us continue with the classification of non-primitive data structures. The first one is linear data structure and the second one is non-linear data structure. So as the name suggests that linear data structure means one data item is linked to the other data item in case of linear data structure. In case of non-linear data structure, one data item is linked to many other data items. So hence it is called as non-linear data structure. Next, what are the different operations on linear data structures that we can perform? So let us continue with the first one, traversal. What do you mean by traversal? It is a process of accessing each data item in a given collection of data items at least once to perform some operation is called as traversal. Next we'll move on to insertion. It is a process of including one data item into the collection of data item is called as insertion. Next is deletion. Deletion means removing a data item from the collection of data items is called as deletion. Next, searching. Searching means it's a process of finding a particular data item in a particular location. Sorting. Sorting is a process of arranging the data items either in a ascending or in a descending order. Next is merging. It is a process of combining the data items of two structures into a single data structure is called as merging. Next we'll continue with arrays. What do you mean by array? Array is a collection of homogeneous type of data items is called as arrays. Next we'll continue with the types of arrays. Of course we have already studied there are three different types of arrays. The first one is one-dimensional array, two-dimensional array and multi-dimensional array. Next we'll continue with one-dimensional array. What do you mean by one-dimensional array? The definition says if we want to access any one element with the help of index with only one index is called as one-dimensional array. Next, the array can be denoted as data type, array name, and inside the square bracket we are going to write the size and put semicolon. Now let us continue with the features of array. The first feature is array size should be positive number only. And next we'll continue with the second one, string array always terminates with null character. So that is /0. So it is one of the escape sequences that we have already studied in the previous year. Next, the third one is array elements are counted from 0 to n minus 1. Okay. Next we'll move on to one-dimensional array, calculating the length of array. So how to calculate the total length of array? So let us take L is equal to UB minus LB plus 1. L is length of array, UB means upper bound minus lower bound. Here lower bound is always 0 plus 1. Why plus 1? Because always index number starts from 0. Hence we are going to add plus 1 to get the exact length of the array. Next we'll continue with the example. If an array A has values 10, 20, 30, 40, 50, 60 stored in a locations 0, 1, 2, 3, 4, 5, then here you can see UB. So that is UB is upper bound is equal to 5 and lower bound is always 0 because index number starts from 0, right? So next, size of array L is equal to UB is what? UB is 5 minus LB. LB is, you can see here, this LB is what? LB is 0. So here you can write 0 plus 1 as it is. So 5 minus 0 is 5. 5 plus 1 is 6. So hence the length of the array is 6 in this case. Next we'll move on to representation of one-dimensional arrays in memory. So location of A of P. So here A is the name of the array and P is the position, is equal to base of array. So plus W means words per character. Okay, so that is number of bytes per character. If it is char, it takes 1 byte, then W will become 1. And in case of floating point number, here it takes 4 bytes of memory, hence the W will become 4. If it is double type of data, then W will become 8, because double will take 8 bytes of memory. Yes, so if it is char type of data, will become 1. Next we have got P, so that is position minus LB, that is lower bound, that is always 0. Yes, next let us take one example here. A, B, C, D, E. Total 5 elements are there in an array, and A, B, C, D, E are the char type of data. So obviously here the value of W will be 1. Now let us see the locations of this particular array. 1000 is the address of the first element A, and the name of the array that we have given is S of 0 here. Okay, so A represent S. Okay, so 1001 is B, 1002 is C, 1003 is D, and 1004 is E. So S of 0 to S of 4. So instead of writing A, here you can write S. So that is name of the array. Next you can see address of S of 3. So address of S of 3 means what? I want to calculate the address of this element D. So what we will write here is address of S of 3 is equal to base of S. So that is base address is what? The address of the first element, that is in this case it is 1000, correct? Plus W. W is here, it is 1, because character type of data will take 1 byte of memory. So P is position. So we want to find the address of the element which is in a third position. So minus LB is what? LB is always 0. Here you can see the base is 1000 plus W is 1, and P is what? Position, that is 3, minus LB is 0. Now you can multiply this one inside the bracket. So 3 minus 0 is 3, 3 ones are 3. So 1000 plus 3 is 1003. So here you can see S of 3 is having the character D, which is at location 1003. So it is verified. Yes. Next we'll move on to basic operations on one-dimensional array. So traversing, once again I'm going to repeat, traversing is a process of accessing each data item at least once to perform some operation is called as traversing. Next, searching means finding the location of the data item. Next is sorting is a process of arranging the data items either in ascending or descending order. Next, fourth one is insertion means adding one data item into a collection of data items. Fifth one is deletion, the process of removing a data item from the collection of data items is called as deletion. Next, sixth one is merging. Merging is the process of combining two data items of the structure into a single structure is called as merging. Now, traversing a linear array. So traversing a linear array, we are going to study the algorithm. So what it says, so this one we have already studied in PU1, that is printing all the array elements. First we are going to accept array elements and we are going to print the same elements. So that is inputting the array elements and printing the same element onto the console. Means what? We are entering element by element and then we are going to printing the element by element onto the console. So here you can see we have got for is the looping structure, location that represent I, that is index number. I is equal to LB is what? Lower bound, that is 0. LB to UB, UB is upper bound. Upper bound could be any number of data items. So here let us take n. N is what? N could be any number, correct? So next we'll go for process A of location. So A is the name of the variable, that is array variable, and in the square bracket we have written location. So it is similar to A of I. Okay, so end of for. So here processing is nothing but it could be inputting or it could be outputting, and then exit. So in this particular case we are trying to access each element to process, so hence it is called as traversing. Okay, so now we will see a small programming example to input and output array elements, so that we can understand how exactly the traversing works. Here we will write single line comment input and output elements of an array. Let us continue with hash include iostream dot h hash include conio dot h. Then we'll write void main, and here we are going to declare the variables as int a of, for example, 10 as the size. Next I n. Okay, next we'll write cout enter how many elements. So here we are going to take cin and n, and now cout enter the elements. Next for loop. So here you can see it's transfers of a data item. So here I'll write I is equal to 0 and I is less than n, I plus plus cin, and here you can see a of I. Next we're going to write cout the elements entered are, again we are going to print the same elements which are entered. Here we'll write cout, so we'll write for loop, then here I is equal to 0, I is less than n, and I plus plus, and then we are going to write cout, and here we want all the elements. So here I'll write a of I, then we'll write get ch closing braces. Now let us compile this program. Compile, success, there is no error. Next click on run. Here you can see how many elements it is asking. So let me enter 5 and enter the elements now. So I'll enter 1 2 3 4 5. Now you can see the elements entered are 1 2 3 4 and 5 is printed. That's all in this video. Thank you very much for watching this video. We will see you in the next video.